So now we can begin by finding the midpoint. The midpoint here, this one here. So you know how to get the midpoint. If you are having points A and B, you can get the midpoint here. Because now here we want to satisfy condition number 2. That the line joining points P and the midpoint AB is perpendicular to AB. So we want to see the line that joins P and M, the midpoint. Is it perpendicular? Is it perpendicular to AB? Then if it is perpendicular, it means that this P here lies on that line. But if we find that like P is here, and then we find that P and M is not perpendicular to this one, then it means this P cannot be lying on this perpendicular what? On this perpendicular bisect. I don't know whether you're getting me, but you get me and see. So now here we shall first find the midpoint M. So midpoint, you know how they get the midpoint. Midpoint is equal to what? You can say x1 plus x2 out of 2, then comma y2 plus y1. Okay, it can also be y1 plus y2, then out of 2. That is how we get the midpoint. So remember, we have points A and B. We have points A and B. So according to our points there, we can call this one y1, x1, y1, then here x2. This one is x2, then y2. Wow. So when we do that, we come and substitute here. So from here, let me write the points here so that they don't disturb me. So I have the points here. So this is x1, y1. This is x2, y2. Now I'm going to find the midpoint. So here x1, you're seeing it, so it is -1 plus x2, which is 5 out of 2, then comma, then y1 here, y1 is here, -6, then plus -8 out of 2. So what does it give us here? This is 4 out of 2 out of negative. It's -14 out of 2. So you have the answer as this one is 2, so it's -7. So this one is the midpoint M. Okay, so after getting the midpoint, we shall now get the slope of P and M. Okay, the gradient. You know they get the gradient. So gradient is equal to change in y2 minus y1 out of x2 minus x1. So the gradient here is what? So I have this point, okay, which is M, then at point P, because I want to get the slope of P and M. So remember P here is 3, -4. Wow. So this one can be x1, y1, x2, y2. Naming this one does not matter. You can also call this one x2, y2 like that. So it doesn't matter. So y2 here, y2 is -4 minus y1, which is 2. Now these brackets are not there. Out of this x2, this is 3. Then minus I've made a mistake. Okay, y2 here is -4. Then y1 here is -7. Yes. Then out of this one here, x2 is 3. Then x1 is here, so minus x1, which is 2. So the answer will be what? -4 plus 7 out of 1. So the answer is 3. So that is the gradient. That is the gradient of line PM. So this is gradient of PM. Now we shall also find the gradient of AB. The gradient of AB, I want to satisfy condition 2. The gradient of AB. So we come here and say gradient of AB. The same, y2 minus y1 out of x2 minus x1. But remember A is here. So this one is I've already named. So I come here and I write. So this one will be equal to what is our y2? Y2 is negative 8, isn't it? This one. Then minus our y1, which is this one. So minus 6 out of x2, which is 5. x2 is 5, isn't it? Yes, x2 is 5. Then minus 1 minus 1, isn't it? So here we shall be getting something like so this one will be minus 8 plus 6 out of minus, this is 5 plus 1. So this one will be getting what? Negative 2, I think. Negative, yeah, it is negative 2, of course, out of 6. Then we cancel this one by 2, 1. So I have the answer as negative 1. So it should satisfy the condition of perpendicular lines m1 times m2 is equal to negative 1. So you can choose to call this one. M1, the gradient we got at first of PM. Then here, the gradient of AB, I can call it M2. So when I multiply, so M1 here, M1 is 3, and M2 is negative 1 out of 6. So it should be giving us negative 1. So equals this one and this one. So I remain with negative 1 here, equal to negative 1. So it satisfies the condition. So since it satisfies this condition number 2 here, it means now the point P lies on the perpendicular bisector of AB.